Welcome to The Explainer. Today, we're breaking down a huge shift in artificial intelligence. We're moving beyond AI that just answers your questions and into a world where AI can actually get things done.
For years, the AI most of us have been using has been kind of passive. You give it a prompt, it spits out an answer. And that's fantastic for specific tasks. But what we're seeing now is a totally different game. We're talking about autonomous agents, a new kind of software that doesn't just respond. It can plan, it can take action, and it can achieve goals all by itself.
And this isn't about replacing the AI we already know, it's really the next logical step. It's about taking a powerful language model and turning it into something that can actually do things. So, how does that whole thing tick? Let's dive in.
So what's actually under the hood of an AI agent? Well, the core architecture is surprisingly simple to grasp, especially if you think about it like the human body. It really just comes down to three key parts. First up, you've got the model. This is the brain of the operation. Think of it as the core reasoning engine, like a Gemini or a GPT-4 that does all the heavy lifting, all the thinking, processing, and planning.
But of course, a brain is pretty useless without hands, and that's exactly where tools come in. These are things like APIs, databases, and code functions that let the agent actually do stuff in the real world, like search the internet, check your calendar, or pull data from a database.
And what connects the brain to the hands? Well, that's the orchestration layer. You can think of this as the nervous system. It manages the whole shebang, gives the agent a memory of what it's already done, and makes the crucial call on whether the next move is to think some more or to use one of its tools.
Okay, so we've got the brain, the hands, and the nervous system. How do they actually work together? Well, it's not a one-and-done kind of thing. It's all about a continuous problem-solving cycle. People call it an agentic loop that lets the agent think, act, and then learn from what happened.
It really boils down to this 5-step loop that just repeats itself over and over until the job's done. First, it gets a mission. Simple enough. Second, it scans the scene. What do I already know? What tools can I use? Third, the brain comes up with a plan. Fourth, it takes an action by using a tool. And then fifth, and this is key, it observes the result, learns from it, and then starts that whole loop all over again.
Let's make this real for a second. This example just makes it so clear. You ask a simple question, where's my order? So the agent thinks and creates a plan. Then it acts, it calls a tool to find the order. Then it observes the result. Great, it found a tracking number. So it acts again, using that number to ping a shipping API. It observes the new result, out for delivery, and only then does it take that final action of giving you the answer. It's a whole chain of thought and action.
Now, this basic loop of think, act, observe, this is really just the starting point. You can actually scale this up in complexity, which creates totally different classes of agents with wildly different powers. The best way to think about it is like climbing a ladder of capabilities. So at the very bottom, on level 1, we've got what you could call the connected problem solver. This is an agent that can use a tool for a simple one-off task. You ask it, what was the score of last night's game? It knows it needs to use a search API to find that info, and boom, it gives you the answer.
Then we take a step up the ladder to level 2, the strategic problem solver. Now things get a lot more interesting. These agents can handle complex multi-part goals. So if you ask it to find a good coffee shop halfway between two addresses, it knows it needs a whole plan. First, use a maps tool to find that halfway point. Then, use a different tool to search for coffee shops in that exact spot.
But this, level 3, this is where it becomes a total game changer. The big idea here isn't to build one single, all-powerful super agent. No, the real magic is in creating a team of specialists, a whole system of different agents that work together, just like a human team would.
And this slide just lays it out perfectly. You've got a project manager agent, and its mission is to launch these new headphones. Does it do all the work itself? No way. It delegates. It tells a market research agent to go analyze competitor pricing. It tells a marketing agent to draft a press release. And it tells a web dev agent to code up the new product page. Incredible. And at the very top of the ladder, well, now we're talking about the real frontier. This is the self-evolving system. This is a system so advanced, it can spot its own weaknesses and then, all on its own, create new tools or even brand new agents to fill those gaps on the fly. It's a system that literally learns and grows by itself. So, what does all this actually mean for us?
This whole shift towards autonomous, collaborative agents. Well, the implications for how we work and build software are, frankly, profound.
This quote just nails it. It signals this fundamental change in our role. For a long time, developers have been bricklayers, carefully coding every single logical step. But in this new world, the developer becomes more like a director. You're setting the scene, giving the agents the right props and tools, and then guiding their performance to achieve the goal.
And that leaves us with a really provocative final thought, doesn't it? As we get better and better at building these incredibly capable teams of AI agents, our new digital collaborators, we have to start thinking really seriously about how our own work, our own skills, and our own roles are going to have to evolve right alongside them.